When you submit the job as a client, when you submit the job to the job tracker, it is a responsibility of the job tracker to execute that job, right?
Mm-hmm.
So job tracker is what the resource negotiator to us. It is going to negotiate the resources, and the same ZAR file that you submit to the job tracker, it is going to send to all the task trackers. The same ZAR file is going to be sent to all the task trackers, and the task tracker, with the help of tasks. A task is nothing but the same ZAR file running inside the JVM. This is JVM, and this is one more JVM, and one more JVM. So the same ZAR file is going to be executed. This JVM is going to process one split, and this is going to process one more split, and this process one more split. Nothing but the blocks. And how these splits are being decided based on the input format. So we have seen all that story. If you look closely into this entire, you should understand that your job tracker here is the resource negotiator. It is going to negotiate the resources. It is going to negotiate the resources, and those resources are assigned or allocated to the job execution, and thereby your job is going to be executed comfortably. So your job tracker is taking care of executing the job. I mean, is taking care of scheduling the job, executing the job, negotiating the resources, doing everything. Your job tracker is doing everything. It is working as all-in-one kind of thing. It is working as all-in-one kind of thing. Now that is going to be, you can see this diagram very closely. What imagination you are getting, I don't know, but if you look at this one closely, in Hadoop 1.0 and in Hadoop 2.0, your MapReduce is taking care of cluster resource management and data processing. Now that is being offloaded to one more layer. So the advantage part is we can have different data processing layers on the top of it. All these days, as part of your Hadoop ecosystem, you are able to build only the components that ultimately drill down to MapReduce. That ultimately drill down to MapReduce. But now interesting, you are able to bring a layer in between so that MapReduce is one kind of jobs that can be executed on the cluster. There can be other distributed computing jobs running on the same cluster, So your cluster utilization can be improvised. Your cluster utilization can be improvised. If you understand this diagram properly, it has got a very detailed and very in-depth meaning. See, your cluster which is biased only to MapReduce all these days, where you are compelled to write your entire logic using only MapReduce, now you can get leveraged from that situation. How? You no doubt can run MapReduce jobs on the new architecture. Along with that, you also can run other distributed computing applications on the same cluster. For that sake, you need not set up a different cluster. But with Hadoop 1.0, the limitation is you are compelled to set up a different cluster if you want to use a different distributed computing environment to process the data. So as a result, what is happening? Your storage is biased only to MapReduce part. But if you observe closely, your HDFS never puts a constraint. It never puts a constraint saying that only this kind of data is allowed here. You can store any kind of data, but you are allowed to process all the data only using the MapReduce technique. But every processing cannot be implemented only through MapReduce. MapReduce is a programming technique with which we process the data very fast because of the massive parallelism. It doesn't mean that every computing can be implemented only using MapReduce. May not be possible. I hope you got the point what I am sharing here, friends. You look at this diagram. Client submits the job to the job tracker. This is what your Hadoop 1.0 or MapReduce version 1. But the same when you come to your client submits the job, no difference in terms of that. The resource manager is going to negotiate with the node managers about the resources. The resource manager is going to allocate an app master to every application. With the help of the app master, using the containers, the job is going to be executed. That is what the new style of processing your data. Thereby, it doesn't make any difference to me whether we are going to use MapReduce to process the data or some other distributed computing on the cluster to process the data. It doesn't make any difference to me. It doesn't make any difference to me. I can make use of MapReduce or other distributed computing techniques to process the data. So when I submit the job to the resource manager, it just allocates the resources to me for its smoother execution. That's it. Using those resources, you run a MapReduce job or you run some other job, doesn't make any difference. You see here, a MapReduce client submits the job, an MPI client is nothing but like how we have MapReduce, a distributed computing framework, we have something called MPI. MPI is called Message Passing Interface. is called message passing interface. Using this message passing interface, we will process the data, like how we process the data using your MapReduce. We also can process the data using, but of course, the problems that can be solved using message passing interface will be different. It's all a different game. How we are setting up MapReduce, same like we need to set up MPI, and how we are saying Hadoop jar and you run the jar file, same like you should be able to say MPI run, with which you are able to run message passing interface applications. Okay, so that's a different game. Let me show you that, then you'll be able to understand. See here, MPI run -np4, and you are going to specify where you are and where your app is, and you are going to give the arguments, like how you are saying Hadoop jar and all. So which means how I'm setting up my MapReduce on this cluster. Same like I also can set up my MPI run. I'm able to do that one, right? Hadoop. I'm able to do that on the cluster. I'm able to do that. I'm saying here, sorry. So here I'm saying Hadoop, how I am able to get this one, and I say Hadoop jar, how I am able to get this one. Same like I should be able to set MPI run, but I say that it says command not found. How I have set up my Hadoop, same if I am able to set up MPI run, I will be able to run that one also on the same cluster. For that sake, I need not set up a different cluster because it is going to be the same data. So because of this, what is the advantage? Data is the same, storage is the same. You have the storage here. On the same storage, we can have a MapReduce application running. But earlier the problem was these two are tightly coupled. You are able to run only MapReduce applications in the ecosystem, because on the top of storage we have only MapReduce set up. So anything that you build on the top here, Pig, it must drill down to MapReduce. Hive, it must drill down to MapReduce. Scoop, anything you take, they must drill down to MapReduce. Then only you are able to process the data that is stored in the storage. But now, what is happening is, on the same storage, if you see closely, storage is the same. On the storage, I'm forming one more layer. That layer is nothing but yarn, and this is a storage where my MapReduce is one thing and my pig on the top, and through this I'm able to process the data. So along with this MapReduce, I also can have MPI, and I also can have other distributed computing frameworks still sitting on the same. That is the reason why we call this as a resource negotiator. We already has got one resource negotiator. That is the reason why we call this as yet another resource negotiator. That is why we call this as yarn. We already has got resource negotiator. It is not that we are developing something new or we have invented a new thing. It is already there. But this is another resource negotiator, yet another resource negotiator, which is called as yarn. So with the With the introduction of this new architecture, I got the advantage of using the same cluster to process my data of different style. My graph data, my spatial data, let the data be anything, I'll be able to store it in my storage. Storage is not keeping any constraint. So I'll be able to happily store my data. Not only just storing the data, I have the chance to even process the data very comfortably by using my MapReduce. I think now, friends, you are able to clearly understand what I mean by you look at this one. I don't know what you understand from this, but if you observe closely here, yarn MR2 included. So like how we have set up here MapReduce as an integral, as a bundled thing along with your yarn. You want MPI, you need to set up that as a service on the same cluster. I should be able to set up MPI also as part of the same cluster. Able to set up that service on the same cluster. Of course, MPI is not in the vision or vicinity of this Cloudera. You may be setting up separately, and it has got a different management interface, like how Cloudera we have, Cloudera Manager we have. We'll have a different thing for that. We'll not be having the same thing, Cloudera Manager. And nobody knows in the coming days. Cloudera Manager also may introduce one more distributed computing framework. Now already we have one more distributed computing framework. We already has got one more distributed computing framework called Spark. But Spark is a library which sits parallelly with your MapReduce. That is another distributed computing framework. Spark on the same storage. Spark on the same storage. So if you look at this one closely, you understand. See this here. Your MapReduce client submitted the job. You got MR App Master. See that here, MR App Master. And it needs 3 containers to execute that job. 3 containers been given 1.1, 1.2 and 1.3. Your job got executed. MPI client has submitted the job. It requires 4 containers. And MPI App Master is being initiated by the resource manager, and 4 containers given to that one to execute that application. So resources can be utilized, well utilized, with the advent of this new architecture. By introducing this new architecture, I am able to leverage my cluster, not just binded with MapReduce. It can be extended to any other distributed computing framework on the same storage. Getting the point, friends?
Yep.
So this, if you are able to understand, look at this one here. The fundamental difference between, that is why this is called as data operating system. So we are basically moving from batch processing to data operating system. Data operating system. The term sounds different, but it's not. It's nothing more than the same old thing, but we have. You see that here. Yarn can sit along with MapReduce. That is what I was telling before. Tej, Slider, all these are distributed computing frameworks. Earlier you see here, of course, we are showing pgive and all parallel with MapReduce, but there are also again MapReduce kind of thing, right? They're peers. Maybe a layer of abstraction on the top of MapReduce. A layer of abstraction on the top of MapReduce. This is more precise diagram, which you can understand better. You got the point?
I have a question. Yes, please.
Yeah, please.
With confusion, like, for the MapReduce from SD Hadoop 1.0 and 2.0, is it like YAN is MapReduce 2? Can we say that, or is it like I mean, the MapReduce in Hadoop 2.0, you call it as YAN because it's interchangeably used? Is it? I have a little bit confusion here. Or YAN complements MapReduce in Hadoop 2?
Oh, got your point. You have, let me explain that. You have Hadoop 1.0 and Hadoop 2.0, right? In Hadoop 1.0 only, we have MapReduce. Okay. In Hadoop 2.0 also we have MapReduce. But MapReduce version 1 moved to MapReduce version 2. Here itself. This is an old MapReduce API and this is a new MapReduce API. So there is no connectivity with Hadoop 2.0 MR version 2. MR version 2 was there even as part of Hadoop 1.0 only. What is this version 2? Version 2 of MapReduce is I don't know whether you have gone through the API thoroughly or not, but if you see the mapper, the reducer, all these, whatever you are seeing, are interfaces. And the map method, what you have, it has got 4 arguments: key, value, then we have something called a reporter, I believe. One second. If you look into the MapReduce API, r.apache.hadoop.map r.apache.hadoop.mapred, where mapper is an interface, reducer is an interface, all are interfaces, input format, all these things, record reader, all these are interfaces. You take your mapper interface, it has got, your map method has got, yes, output collector, yes, output collector and reporter. You have key value, output collector and reporter. Now with the MapReduce version 2, what has happened is, this is your r.apache.mapred now been moved or shifted to r.apache. Sorry, there is one more thing in between Hadoop. Apache.hadoop. map reduce. This is map read here and this is map reduce. And you see mapper, reducer, input format, all these are classes. All these are classes. Whatever you are seeing here, all these are classes. These are not interfaces. And second thing, your map function has got key value, and what is the third argument? Context object. So your MapReduce version 2 is a context-based implementations. So MapReduce version 1 to MapReduce version 2 has happened there only. That is why you are able to see here in the APIs, if you look closely, here in the, you see here, Apache Hadoop 2.4, where you see you have your Apache r.apache.hadoop.mapred exists, even today it exists, but it is been deprecated, no more in usage by the latest applications. It is all r.apache.hadoop.mapreduce, where mapper is a class, reducer is a class, record reader is a class, input format is also a class, and it is all the context-based implementation. You can see the map function has got key in value in and your context object. Even when you go to the reducer, so this change was there, the context-based implementation was there as part of your MapReduce version 2. But when you come to Hadoop 2.0, what I am showing you here, this is the shift in the architecture by introducing yarn. You got the point here, Ram? So in Hadoop 2.0 also we
Yes.
have MapReduce. How we have MapReduce? We have storage, and on the top we have yarn, and on the top you have MapReduce, and other layers can be other things. So that is why this MR2 included as part of the yarn. This is getting as built in. If other things need to come, you need to set up separately. Because I cannot segregate, or I cannot say I don't support or you need to set up MapReduce on your own kind of thing, then all my legacy applications are going to suffer. So not to happen, along with yarn, MR2 is included. That is what you are noticing here as part of this which you are seeing here, yarn, MR2 included. MR2 included in yarn. What is MR2 MapReduce? Version 2, what I said, that exists even as part of your Hadoop 1.0. So MapReduce version 1 and MapReduce version 2 different, Hadoop 1.0 and Hadoop 2.0 different. Make sense?
Yeah, got it, Srinivas. So adding to that, like if I missed something in the last part that you mentioned, so yarn comes up with MapReduce 2 embedded in that
Yes.
as in Hadoop 2.0, and as well we have MapReduce version 2 without yarn embedded also as a separate entity. Is that
Exactly, exactly, exactly.
okay? Sure.
You can get the same thing. You can get the same thing. Add service, if I say, you look at this one, you have something called MapReduce, only MapReduce. Only MapReduce. And you have yarn, that is included with MapReduce. Which you want, you can use that one. I prefer this yarn because you understand now why it is. See here what it is showing. If I select MapReduce, only MapReduce, they are saying MapReduce 2 included. Yarn where MapReduce 2 included is recommended instead. MapReduce is included for backward compatibility, for where when you set up yarn. You got the point?
Srinivas.
So what is not been set up? That is already been set up. This yarn is already been set up on this one. Will not be because that is the architecture actually. So HBase you want, you can set up now separately. I say because that is not there. HBase is not there yet. So hope this concept is clear to you. Yarn, why basically you need yarn? I think you are clear on that. See this here. So yarn is totally a resource manager, leaving data processing to the respective frameworks. The cluster resource management is completely taken care by yarn. But earlier, MapReduce used to take care of cluster resource management and data processing. Now that is been offered to yarn, where MapReduce only can take care of data processing, not cluster resource management. That is been offered to yarn. That is the reason why we say here the resource manager, your job tracker responsibility is being divided into parts now. The job tracker responsibility is being divided into parts, two parts. In Hadoop 1.0, only MapReduce applications can be processed. In Hadoop 2.0, non-MapReduce applications can also be processed. In Hadoop 1.0, cluster resource management is handled by job tracker, which is a component of MapReduce. And the same is being cluster resource management is handled by yarn. Optimization of resources is better due to the central resource management, no more fixed map and reduced slots. Task tracker and job tracker are responsible for the execution of the application. Yarn resource manager and node manager replaces, see here, Yarn resource manager and node manager replaces task tracker, job tracker. No more task tracker, job tracker in Hadoop 2.0. What we have here? What we have here? We have node manager and your resource manager. For every application that you submit or every job that you submit, you will be having something called app master. You can see the fundamental shift in this. You can see this diagram closely, friends. Job tracker with the help of task trackers going to execute. Resource manager, node manager. On every node, you will have a node manager. And every application that is submitted will have an app master. That is called application master. With the help of node manager and application master, the resource manager is going to negotiate the resources. The node manager allocates to the application, and application master takes the responsibility of executing your application or your job. That is where I mentioned it clearly to you. I mentioned it clearly to you. It is only the fundamental shift in the architecture. How you have submitted your applications and all these days, the same you are going to submit the application in terms of this one also. You understand what I am saying here? Even with your
I have a question, Srinivas.
yeah, please,
Sorry.
please.
Sorry to interrupt you. Yeah.
No. Go ahead. Go ahead.
Sure. For the YAN, as you were saying, we have a better approach here of manually deciding and optimizing the stuff. But as I see, mostly, a lot of industry says like YAN is too complex to, get programmatically done, because like for even a smallest task, like at least like there is like 500 lines of code, like, that you need to write to, and you need to load in memory stuff to execute the YAN, and like, of course you get the advantages, but it's not so easy, like, that we are MapReduce itself is a bit difficult, but now with YAN, like managing the resources manually too. So what's your thought process like? Is YAN still widely used in uh, Hadoop 2, where all the MapReduce are being 80-90% of them are managed by YAN, or they are the MR2 jobs?
Very classical and a precise question. But if you, it has got your question has multiple small questions again. One, your because as you haven't submitted the job in your Hadoop 1.0, we are not able to see the difference. But if you see the development process of MapReduce application, its submission, development process of your pig scripts, hive queries, scoop commands, and all these things, nothing has been changed. It is the same as is. Same as is, we are able to run it even on your Hadoop 2.0. That is one thing we need to identify here. So that clearly states we are not going to change the code in terms, even when you are moving to yarn, we are not changing any code in terms of writing your MapReduce jobs, because it is all been taken care internally. You only submit the job to the resource manager, that's it. Earlier, if you see, when you submit the job, you used to get the information straight away saying that submitted the job to the job tracker. But now, directly you are getting, it has been received by the resource manager. Let me do that for you. Just to have, well, you already did that number of times, but to make you to understand in this context, let me do that. So this is how you run your MapReduce job. See here, forget about the exception. That is all the permission to the route is denied because no right permissions for that. We can address that one. That's not a problem. Leave that one. Only for that group, we have read, write, execute permissions. For other things, we have only execute and read permissions. We don't have write permissions. That is why we are not able to do that one. Take that out. But you see closely here, connecting to resource manager at master.techiebs.com. That is 192.168.159.40.8032. In this place, if it is your Hadoop 1.0, we used to get job tracker. Now tell me, the same examples.jar file, what we have, what changes we made in terms of the code? Did we write any yarn related stuff inside your word count example? Did we made any changes to the code what we have written inside your MapReduce? Same jar file, right? Example jar file. Only thing is, it is now been connected to the resource manager. This jar file is submitted to the resource manager. So all your MapReduce applications going to run as is. When I say all your MapReduce applications, the ecosystem built on the top of MapReduce also will be as is. There will not be any change in that. So this clearly states that we need not write any additional code in getting migrated to your Hadoop 2.0. But yes, the second one, when you need to do things on your own in Yarn, yes, you're right. We need to use Yarn API. We cannot work with MapReduce API anymore. We need to work with your Yarn API. We have separately here. You can see that here. r.apache.hadoop.yarn, and it has got its own client API also. It has got its own security layer, its own utilities, everything. Yarn has got its own. So when you need to manage things on your own, then the amount of code that you need to write with Yarn is definitely high compared to that of your earlier one, but with the advantage of optimally using the resources at your cluster. So to your questions, the answer is yes and then the answer is no, both. So in terms of your legacy applications, when you're moving from 1.0 to 2.0, all your legacy will be as is. They will not suffer or undergo any change, or it is going to run as is. That is one. See, it is not only with Yarn. Any migrations or enhancements definitely will be taking care of accommodating your existing applications. That is not a great thing which has been done only in Yarn. Any enhancement or any enrichment you see, this is one property that has been absolutely taken care. It will not be ignored.
That's the backward compatibility.
Exactly.
Yeah. So.
Right. So taking care of that, the richness of utilizing the cluster resources is been introduced. But with this new architecture, if you need to write applications specific to Yarn, yes, definitely these are expensive in terms of development. the number of lines of code that you need to write with Yarn in terms of managing the things on your own are expensive compared to your MapReduce version 2 or your Hadoop 1.2, I guess. Make sense, Sarah?
Yeah, that's a great answer. I got that, Srinivas. And added to that, like one small other question.
Yeah, please, please.
Yeah. Uh, so I got this, whatever you explained. Now, if I have an existing MapReduce from Hadoop 1.0, which is MR2, MapReduce version 2, and I want to write a yarn to embed or to submit that MapReduce job. So can we also do that?
Yeah. Definitely. Definitely. But the only thing is we don't need that because that is been taken care by the resource manager implicitly. That is been taken care by the resource manager implicitly. The same MapReduce implementation what we did before, that is where it is getting connected to the resource manager. See, if it is getting connected to the, because the job tracker itself has been vanished now. Job tracker doesn't exist. With your Hadoop 2.0, that is where Yarn, MR2 included inside, you don't have that job tracker at all. You don't have the job tracker at all, and the task tracker. It's all been I can say overlapped with your resource manager and node manager. So as a result, we are getting connected to the resource manager directly whenever you are submitting even your application developed targeted for Hadoop 1.0. But you want to write specifically the Yarn client. You can always so from the same again, we don't have any see here. Yarn client dot create yarn client dot init of conf, and yarn client dot start. You can see that here. You remember from your MapReduce version, I mean Hadoop 1.2, instead of saying MapReduce because again you'll get confused. So in Hadoop 1.0, if you see what the code we used to write inside, job, job conf and all those things, right? You remember?
Yeah, right. So we use the jobs there and we use the resource manager here.
Right? So we are going to use those things when you come to that one. But when you come to this one, you are going to make use of all the resource manager abilities. All the resource manager abilities. So yarn client dot submit application, and it is going to be done something like this. So yarn client dot submit application, yarn client dot submit application, and you cannot just app context. This app context need to be filled with all. I think you noticed here. Whatever we are doing, whatever we have done it using your let me open that API even. There we have all this stuff r.apache.hadoop.mapreduce. If you go there, you have something called job. On the job we used to say what the methods we used to call job.set. What is a mapper class? What is the combiner class? What is the reducer class? And set by jar. All those things we used to do. What is input format? What is output format? So all those things we used to set. Still that is allowed, but you want to use directly. I mean, you want to develop a yarn based job directly, then you need to make use of the API, something like this. I think you are noticing here. App context dot set EAM container spec. Are you looking at this one, Ram? Whatever I'm showing you here.
Yeah, Srinivas.
So app context dot set resource, and then you need to do all these things. You see here yarn configuration object, instead of you going with your earlier configuration object, now you are going with the yarn configuration object and do all those things. Then only we are able to say yarn client dot submit application of app context. You
You mean
cannot
in that app context, you are, I mean, in between you are mapping the
exactly
MapReduce job
all
jar
that.
file.
No, we are not mapping. We are directly. That is where I am saying here that MapReduce will not come into picture at all. We only bother about the resources and all. As part of that, you run whatever the application you need. That is where you get confused actually with this yarn-based architecture. That is why we don't go to the yarn-based implementation in terms of the code. You still work with the same MapReduce, because your whenever you write a MapReduce code and submit to your cluster, your resource manager takes care of receiving that one and allocate the resources and get it done. Now, if you are developing a fresh, yarn-based application, you need to write all this code, whatever you are seeing. There, MapReduce will not come into picture at all. At yarn level, MapReduce is only a part. MapReduce is not
So
everything.
you manage, sorry to cut you. So you manage like the mapper, like whatever we write in a MapReduce job, the mapper reducer code and the client code, everything is embedded inside the yarn. Is that what you say?
Exactly, exactly,
Okay.
exactly. So that is where you will get confused, because when you're talking at the yarn level, we never talk MapReduce. We only talk resources. We only talk resource manager, node manager, and we only talk at that level. We never talk because MapReduce is nowhere related to yarn. Is nowhere related to yarn. Yarn is completely the resource manager, the cluster resource management. That is where in this diagram you see very clearly it has been mentioned. That is why that MapReduce related code will not come into picture at all when you are working with your yarn API. You look at this one. Yarn is cluster resource management built in with data processing. The data processing is MapReduce. You got the point?
A little bit confusion here. So you say like the MapReduce job is separated from the yarn resource management code.
Exactly.
It's
Exactly.
not embedded inside yarn. But earlier we saw like, MR2 is part of, I mean, if you
No,
want to write a
not
yarn,
writing. No, not writing. That is only embedded as part of your yarn in terms of yarn built in with MR2. The meaning of this one is MR2 is included as part of the yarn. I mean, to have your backward compatibility, this has been included. Suppose if this is not there, assume RAM, then every application needs to be rewritten using yarn based APIs. You got my point? Say
yeah,
all say all these days you developed MapReduce applications. They're already there, piled up, all MapReduce applications, right? Now these needs to work with your new architecture seamlessly. How? As usual, Hadoop, ZAR, and you run it on the same cluster as is. Not even a change in the command also. Whenever you say Hadoop ZAR, it gets submitted to your resource manager, which is a part of your yarn. So they run as is. They run as is. No difference in terms of that. Suppose if this compatibility is not been provided, then what needs to be done is your MapReduce applications need to be rewritten using yarn. That is what the meaning embedded, or that is what included. Okay. So if that is not the case, then you need to, let me show you that, then you'll be able to understand. Because as that situation is not required, that is why we don't have those implementations, but still I'll find it out for you. Let me, from the same this thing, YAM, let me get that for you. See here, app context. I want to show you how this jar file is going to be added to your.
So you mean the existing
Exactly.
MapReduce job? You
Yes.
set the path of the jar file in the yarn, and I think
Exactly.
right, class path.
Because the reason why we don't do that, or why we don't go for that implementation, because when it supports directly your backward compatibility, submitting your applications as is without any additional changes and all. So we don't rewrite that one basically. See, if you are rewriting, then there is no point of yarn supporting your backward compatibility, right?
Right, right. That's I agree with that, Srinivas. But let's say we have some legacy MapReduce jobs which you want to run as is, where the resource manager is used,
Yeah.
and you have some enhancements. So the enhancements you want to take care using Yarn, where you want to manage, the sizes using the resource manager manually in the Yarn, as well reduce the mapper and reducer inside the Yarn as per the Hadoop 2.0 specification.
Because that is what,
In that case, we need to go for Yarn, right?
no, we need to go for yarn, but thing is, you cannot, there is no point to you uh, working with the resource manager or node manager for the sake of resources, doing things on your own. It is been implicitly taken care by your resource manager itself. When you submit the job, so your resource manager understands for this particular job what are the resources required and how to negotiate those resources with the node manager and allocate those resources in the form of container. And those containers are dedicated for that job execution. Once that is been finished, those containers are being freed. But thing is, we need to have first step the client needs to do is to initialize and start yarn client. That is fine. Dot create application app dot get new application now. Okay, app context dot set application name, app name, that is fine. Yeah. Somewhere here only we'll have that yes file system, local resources. 'App context dot set am container spec', whatever we have done till now using am container, all been set to your app context. So app context dot set priority, app context dot set queue, uh, submit application, yarn client dot get application report of app ID. So here, one second, Ram, 1 second.
Sure, Srinivas.
So here container request, get progress. Um, we have, I'll give you the code that needs to be used here, Ram.
Sure.
How you can make the same jar. See, after getting all the containers and all, I think you are seeing here. See, this all is not there as part of your job tracker aspect, right? You are saying just on the job, you are saying job.set all the details. What is a mapper, reducer and all, and you are just submitting to the cluster. It is taking care. So the resource management is being completely taken care by your job tracker. Now that is been offered to your, that is not been the responsibility of the job tracker anymore. Job tracker responsibility is only to run your application, but not taking care of allocating the resources. So in the same this thing, how the jar can also be included. Let me get that, few lines of code so that you understand how the same jar can be included over there. So this code remains same. I think you are noticing here how we are negotiating the containers from the resource manager and getting it allocated to your application execution. I think you are seeing here. So whatever you mentioned before, the code, the huge lines of code that needs to be written to make up your yarn based applications is this headache only. You need to have, you don't have this kind of life cycle when you go to your Hadoop 1.2. So simple, using your API on the job, you do all these set methods where you are able to set all the details and submit to the cluster, you are done. But when it comes to yarn, it is not that simple like how it was with Hadoop 1.0. You need to do all these things. You need to understand this API and you need to set all these objects. You need to set the application master container. You need to set the application context, and then only finally you are able to run your or submit your applications. You cannot submit your applications just like that. You need to first get all these resources, then only you need to submit your application to your resource manager. But while submitting this application, how you submit this MapReduce application also, along with that, I'll find it out and I'll let you know. Because that situation never arises for the reason, without doing all these things, directly we are able to run it, that backward compatibility being given. So we need not take the pain of rewriting the application using your new yarn based implementation. Same as is you run, but that is going to be taken care. Now I tell you, see what all we are doing here. What we are doing, see here, resource equal to resource dot new instance, memory and application master memory and application master virtual cores. We are supplying to that one. App context dot set resource of capability. You are getting my point. So this all we are doing. This all we are doing it programmatically. Then we are submitting it. But if you look at this code, what we have executed, directly we are connecting to the resource manager when we are submitting the job. So what it will do, it internally does all these things, whatever you are writing here. So whenever you are submitting a job using your Hadoop ZAR, it is directly taking you to connect to your resource manager, so that we need not worry about writing all this stuff to negotiate the resources, get it done and all. But when you are building a yarn based client on your own from scratch, it is your responsibility to do all that stuff. What is that? I mean, filling all these context objects and filling all these yarn based Java objects with all the details, and then only app context dot set AM container spec. We are giving the AM container, and that AM container will be using it some other place. App context dot set queue, that also we are setting on the app context. Finally, that app context we are passing it to your submit application. With all these details only, your application is going to be executed against your yarn infrastructure, right? So without all that pain, directly we are running your MapReduce applications, connecting to the resource manager, so that for this particular application, what resources are needed, it is going to negotiate and assign it for the smoother execution of that one. That is what the backward compatibility is. That is the reason why we are not compelled to look for the implementation of or rewriting of all the existing MapReduce applications in yarn. But let me look into that. I'm sure we'll have a provision how we can rewrite your existing MapReduce application using your yarn base and get it executed. When resource manager is able to accept that and run it, definitely it is been provided by the API only. Without the provision from the API, even it is not able to run it, right? So what is that internal implementation with which your MapReduce applications are being executed by your resource manager? I'll update you on that.
Sure, that'll be really great.
But because
what I see is to whatever. Yeah, sorry.
Because of this backward compatibility only, we are not compelled to do anything on that. That is why we don't do that. But as we need to specifically look into that, yes, we will definitely identify how it is happening and we'll look into that. No issue for that. Yeah. Go ahead.
So as I understand from your explanation about existing MR2 and the YAN, I see like in MR2 the resource management is automatically done internally, but in cases where you want to, I mean, you have a flexibility in 2.0, Hadoop 2.0, where in some cases where you are intending to use the memory as I saw in the code of YAN, like you were explicitly giving as parameter, like, how much of memory you want to allocate for that job. So in that way, you can optimally utilize the existing resources instead of like resource manager by itself deciding like, fixed set of memory being given regardless of the size of the job.
Yeah, even CPU cores also. So you can manage things even from your end. I mean, with your code, whatever you are writing. And that's what the beauty part, which is not that flexibility. If you go back to your API and see, That flexibility is not being given anywhere in the MapReduce. You go and see the entire MapReduce, nowhere we have that flexibility. That is all been taken care by the job tracker only, internally. Your job is only to submit to the job tracker. It is the responsibility of the job tracker to take care of both the things. What are the things? Resource management and data processing.
The job execution. Yeah,
Yeah,
data processing.
the data processing. Both are being taken care by the job tracker itself in your Hadoop 1.0. But in Hadoop 2.0, this resource management is nowhere being taken care by the job tracker. Of course, job tracker does not exist here at all, but if you think in that angle, resource management is not being taken care at all. The only thing that is being taken care is data processing. How data processing? Because your code is getting executed, right? So that code is going to take care of processing the data. That's it. Nothing more than that. But resource management and all been taken care by resource manager. That is why all your MapReduce applications, when being connected to the cluster, your resource manager directly comes into picture and takes care of negotiating the resources and allocate to your job.
Yeah, got it, Srinivas. Great explanation. And for the writing the basic YARN, so we need a, as I understand from your conversation, is it we need a YARN client and we need to write a YARN resource manager as well?
Yes, yes. No, we need not write the resource manager, but we need to give
The
all the
YARN resource
necessary
manager.
inputs to create your containers and to create your context objects and all. Then only you are able to submit the application. Because if I need to yarn client.submit application, I need to pass app context. I cannot pass the app context with the default values. So this app context needs to be set. I think you are seeing here. App context dot set priority, app context dot set queue. All these needs to be filled. Then only you need to go, give that app context to your submission. With those filled in details only, your application is going to be executed.
Which is all part of the YARN client, you mean to say? We want to do all this as part of the YARN client.
Exactly. YARN client. Whatever you are seeing here, this entire thing is YARN client only. That is where writing simple YARN client will have you can directly do this one with the default configuration and all. You can get it done. But you want to go in a detailed manner, you need to use all these things, whatever the code. So as you mentioned in your question what been asked, from that only we came all the way here. So you are right in that context. That is why I have given the answer yes and no. Yes, because when you are compelled to write things on your own, the lines of code that you write here is horrible. Definitely this is very expensive. Very expensive compared to that of your MapReduce, what we have done in Hadoop 1.0. Right? In that way, this is definitely expensive. But in the other way, if you see, the most critical thing of your cluster is resources. When resources are able to be optimally utilized, you can make the same cluster to run or accommodate more jobs so that the cluster is being optimally used. Right? So with that advantage, taking the pain of understanding the API and writing it accordingly should not be a problem.
Sure, got it.
Right? But for sure, I'll let you know. Let me work on that one because that situation has never arisen, to be honest with you, to rewrite things with Yarn again. That is why we will not, because if that situation arises, there is no point giving backward compatibility as part of Yarn, but still internally also it is using the same API to get things done. What is that internal to get your MapReduce application run with your resource manager? I will update you on that.
Sure. Great, Srinivas.
So wonderful. Hemal, I think, I don't know,
He stepped out, I guess.
Oh, stepped out, I think. Okay. Right.
Yep. So, still like for the code part, like I think from your side you already have
No,
given, but
not
it's
yet
still not
been kept
accessible in the
there,
blog.
Ram? Not yet been kept there?
No, in the blog I still don't see that. Like,
Is it they kept it as a Google Drive and they're not sharing the link on?
or maybe
Oh, I'll
that's because
no,
it's not.
no. Tonight I think they'll be back evening. I mean your daytime, Ram. So let me work
Sure,
with
sure.
them, and if possible, try to get the access and make sure that he's available to you, Ram. Sure.
Sure, sure. Whatever
Sorry
best
for
you
the delay.
can, like,
Anyway,
yeah, no problem. Whatever best you want to give us, like, because with the short time that we have, like, we
no.
can see the all the codes that you worked, and like, we can run that and have a feel like.
True, 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 true.